Averages appear everywhere in the context of share prices, fund performance, inflation data, and so on. So in this video, I just want to ask one simple question, which is, can you trust the average figure in front of you? And the answer is you probably can, provided you know which average you're looking at. So here's a short video that covers all the basics. In a nutshell, what are we trying to do with an average? Well, here are some share prices over 10 days in total. Prices up the side, so there's 100 pence and so on. And a simple question to ask would be, what is the average share price? Now, you might be able to see it from a kind of casual glance, but most people probably won't be able to, bearing in mind that these share prices bobble around as they tend to over 10 days, ranging anywhere on the downside from sort of 90 up to 160 and quite a few places in the middle. So what is the average? Well, mathematically, the most commonly quoted average is the mean, the simple average if you like. This takes all the items that we're looking at and divides by the number of them there are. So here I've just added up all the share prices I just gave you, divided by 10, that's how many there are. So the average comes out at 117. Now, if you were to glance back at the previous chart, you might say, well, that seems about right. The range, if you like, is somewhere in there between lowest and highest, which is 90 and 160. So 117 is somewhere in there. And you'll notice something straight away, which is that we've got a couple of almost sort of outlying pieces of data, 150 and 160, and those can be dangerous in the context of a mean because they can skew it. So let's take a look at some of those pros and cons now. So the mean is relatively straightforward to calculate. All right, it's used commonly where data is linked. In this case, share price data over 10 days, and it uses all of the data available. Those are sort of plus points, if you like. The outlier problem I've just mentioned, and it comes up in several contexts. One of them, for example, I've listed there is average bank salaries. You'll see investment banks say our average staff are paid $300,000 US, but if, frankly, you're not at the top of the tree earning the big bonuses, you won't be earning anything like that. So the fact there are very few people at the top earning loads of money skews the average up for everyone else to make it almost meaningless. Or you might look at the average number of days in a month, and I've done that, and I came up using this method with 30.42. And the problem with that is no single month actually has that number of days in, 28, 30, 31, so the mean gives you a slightly odd result. 117 over here doesn't correspond with any of these data points. So just bear that in mind when you're looking at the mean. Now, is there a way also of testing the outlier problem? Is there a way of sort of getting a grip on whether or not the mean is representative of the data you're looking at? And the answer is yes, and it's called the median. So the median ranks all the data in size order. So looking at those 10 days worth of share prices, you'd simply take the lowest, rank all the way up to the highest, and then look for the one in the middle. Now, you can do that mechanically, manually, or with a spreadsheet, but essentially what I'm doing here is saying top and bottom, go, next two go, next two go, next two go, and I'm left with those two, 110. The median, presumably, therefore, is 110. All right, now, just watch out for the fact that when you've got an even number of items, you will have to sometimes average the middle two to get the median. Here, they're both 110, so that's not too much of a problem. With an odd number of items, the median will be the middle item. And this can be quite a useful way of judging how representative the mean is of the data you're looking at, because if the median's a long way away from the mean, you may have a problem relying on the mean as being representative. So, over on the right-hand side, it represents the middle value. It's not skewed by outliers like the mean is. It's quite a good check on the mean. All right, however, beware, it may or may not correspond to one of your pieces of data, depending on whether you need to do that averaging exercise to actually get your median. Can be a bit of a pain to calculate. I mean, with a spreadsheet, it's not too bad, but rearranging data and then working out where the middle one is can be a bit annoying. Quite a useful way of checking the reliability of the mean. So there it is. So we've got the mean, we've got the median, and that leaves the mode, the most common piece of data. Now this one's particularly useful where your data isn't actually numeric. All right, so the most popular colour might be yellow. You can't have the most popular colour being 3.2, if you get my drift. So the mode has quite a number of uses. In the context of this set of data, share prices, what we would do is look for the most commonly occurring one. All right, 90 occurs once, 100 twice, 110 three times. All right, so that's looking like the most popular one, 110. And then we've got 120 twice, and 150 and 160 once each, based on that original data on share prices. So, useful, we're looking for the most popular item, and sometimes it's the only one of the averages you can actually use. It's the least skewed by outliers, which is an advantage it has over the mean and the median. All right, the problem is it may not actually exist, or you may get more than one. So it has, like all these measures, pros and cons. So they have it, mean, median, and mode. Now, just to backtrack slightly to the one that is normally quoted and what most people normally mean by the average, the mean. Just be aware, there are two versions of it. Before we get to those two versions, a very simple way to remember this, if you ever need it in the context of, for example, an exam, hey diddle diddle, the median's in the middle, you add and divide for the mean, the mode is the one that appears the most, and the range is the difference in between. All right, I don't do nursery rhymes too often, but if you had to remember this stuff, there's one you could tuck away. Now, just to take the mean on a little bit further, there are two versions of the basic mean, the arithmetic, which we looked at just now, and the geometric. And here's another trap you can fall into. Which one should you use? You will come across both in practice. I'll sell it by way of an example. You start with £1,000, it says here, and invest it. And you're going to stay invested. Your portfolio goes up 10% in month 1, 10% in month 2, and then falls 20% in month 3. What is your return? Arithmetically, the answer is a bit odd. Because arithmetically, you just take 10%, add 10%, deduct 20%, combine the three items, divide by 3, so you end up with 0. Is that odd? Yeah, it is a bit odd. Because actually, if you work it out, £1,000 plus 10% plus another 10% minus 20%, if you stay invested, comes to £968. So you've lost money. So why is the arithmetic mean telling you your average return is 0 when it isn't? Well, the way to get to your average monthly return is something called the geometric mean. I'm not going to go through this in a lot of detail because no one wants to watch a maths video from me, but the principle is this. You take your 3 data points, combine them together. Because there are 3 of them, you take the cube root. If there were 2 of them, you take the square root and so on. All right, take that result away from 1 and you've got your answer, 0.011, or in layman's terms, 1.1%. So all that number crunching, which is normally done for you, will be telling you that actually you've lost around 1.1% per period, per month in this case, which is why you start with £1,000 and end up with 968. So you can see another trap with the mean is you might use the wrong version or the one that doesn't give you the true picture. All right. Now, why that matters? Well, inflation numbers, for example, if you look at RPI data, that's calculated using arithmetic mean. CPI, the newer measure, uses the geometric averaging method. Result, the CPI, as in my previous example, tends to come out lower than the RPI, and that's worth knowing. Performance figures, if you were to track an index, for example, performance over time, you will get different results using arithmetic versus geometric means, and occasionally that can be a problem with certain types of indices. As a rule of thumb, if you're wondering what's right and what's wrong, the arithmetic mean works on discrete data. So if I was investing my £1,000, taking it back out again, creaming off the return or the income, putting it back in again, taking it out, so each period investing and de-investing, ignoring transaction costs, then the arithmetic mean would give me the right overall result. Normally, of course, you don't do that. So you want the geometric mean. In a nutshell, therefore, the message from this video is very simple. Email me, okay, with any queries. You can't always take a quoted average at face value. In short, know which average figure is being put in front of you.